Hello, and welcome to this Dlubal tutorial. In this video, we will show you how to model a tapered hinged frame in Rhino Grasshopper and export the results to RFEM 6. As usual, we begin with the geometry. First, we create a point using the point command. You can find it in the Params tab. As you can see, this point is orange, which means it does not contain any data. We have to insert data in this command. We can do this directly in Grasshopper, using the construct point or the panel command, as you can see. Or, we can do it in Rhino by right-clicking this command and selecting Set One Point. After that, we enter the coordinates of this point. For example, we enter 0, 0, 0. In order to copy this point in the z direction, we first deconstruct this point into its coordinates, x, y, and z, using the deconstruct component, which is in the vector tab. Afterwards, we insert the construct point component from the vector tab. For this point, we use the same values for x and y, whereas z has another value. To define the z value, we create a new range using the slider number. The range is, for example, from 1 to 10. We enter height for this slider name. Then we add the value from this range to the basic value using the addition component. You can find it in the Maths tab. After that, we create a line between these points using the line component. In the next step, we copy this line in the x direction. For this, we need the move component and the unit vector parallel to the x-axis. We also need to create a new range, for example, between 1 and 15. Then we enter width for the slider name. We repeat the same procedure to copy the points in the x direction. Next we create the apex height. For this, we first need to copy the top point from the first line in the x direction using the move component. To get this point between the two top points, we need to divide the width into two equal segments using the division component, which is in the Maths tab. The first value, a, is the width value. The second value, b, is 2. We can enter it using the panel command. Afterwards, we copy this point in the z direction using the move component. We also need to insert the unit vector parallel to the z-axis component. After this, we create a new range for the apex height, for example, from 0 to 5, and enter apex height for the slider name. We can copy any point using the point command, as you can see. Now we create lines between these points, then we group them and enter names. We can also copy any line using the line command. We do not need this point. Therefore, we can disable it by clicking the mouse wheel and selecting Disable. We can also change the display type from display menu, as you can see. In the next step, we will assign members to these lines. We can do this by double-clicking the canvas and writing member. In this example, we will assign different members to columns and beams. Because we need to define different cross-sections, we will first assign a member to the columns. We also define the member type by using the value list command. For this, we select the beam type. After this, we connect the line components to the grasshopper line in the member component. Now we define the cross-section as well as the material by double-clicking the canvas and writing section and material. To enter the properties of the section and material, we use the number slider for the numbers and the panel for the names. Now we enter these properties. For the cross-section, we enter 1 as the section number and IPE 300 as the cross-section name. For the material, we enter 1 as the material number and S235 as the material name. For the beams, we repeat the same procedure for every individual member, because we will assign a cross-section at the member start and the member end. We will change the cross-section to IPE 500 at the member start. We also need to change the cross-section numbers to 2 and 3 using the number slider command. Next, we select the section distribution using the value list command. For this, we select the tapered section distribution type at the start of the member. For the first beam, we will create a moment hinge at the member end using the member hinge component. You can find it in the Dlubal tab. For this component, we also need to enter a number as well as the hinge conditions using the panel command. Next, we define the supports. For this, we double-click the canvas and write nodal, then choose the component from the list, as you can see. Now, we would like to create hinge supports using the panel command. Then, we connect this panel to the respective support conditions. Now we group together all the sliders and enter parameters for the name. Next, we transfer this model data to RFEM. We have to insert the Dlubal component, RFEM6 export component, by double-clicking the canvas, then writing export, and selecting this command from the list. To start the export, we use the Boolean toggle command. We overwrite the previous data in RFEM by using the Boolean toggle command and switching it to true. After connecting all the components to the RFEM6 component, we double-click the Boolean toggle command to perform the export. All changes to the parameters in Grasshopper now have a direct impact on the RFEM model. Thank you for watching. If you have any questions, feel free to ask them in the comments below. If you like this video, don't forget to like and subscribe.